So the title of my talk is Geospatial Science in the Anthropocene. Is it a panacea for disaster resilience in developing countries? I want to believe that everyone who is seated in this room is probably more familiar with geospatial knowledge. So if the title is framed in terms of, in form of a question, one can have a binary choice of saying whether the answer is yes or it is no. And we did get some indication, some kind of appetizers from the remarks of the principal, the head of department, and the moderator. So with this title, I was trying to see how then does it fit in the overall focus of, overall theme of the conference, which is looking at emergency, it is looking at resilience, it is looking at resources. So I will start by giving some few pictures picked from Uganda. For those of you who have ever traveled to the east and you have been to Mountain Elgon, it's a very heterogeneous environment in terms of the physical setting, in terms of the social setting, even though generally speaking, you can take it to be a mountainous environment. But if you have been to the areas of Kwen or Kapchora, then you get to those areas or those settings where clearly the issue of degradation can be observed on the landscape. And when you speak to the communities, they are quite surprising. They are always referring to this landscape as being a ripped landscape or a naked landscape, meaning that they do have some kind of understanding of what it is or what their actions are sort of changing that specific landscape. There is a big story to do with that, but of course we don't have time. But if you look down, you also see a picture of Kampala. The principal here was saying he's young, but not very young. I don't know if he ever boarded some of those buses that existed in the past or they are post him. So you can have this kind of change in space and time, but overall it does give us an impression of the so-called, the signatures in the so-called Anthropocene. Now, you don't normally find this in a setting like Sadat or a setting like, let's say, Hereth, but if you go in geology, then you have these sort of long time scales. You can talk about the whole scene. Anthropocene is what we have now, but typically depicting the human footprints that are more visible now than in the past. So then, these are just examples, but there are very many across the world. The question we can ask is that with these changes or with these signatures of the Anthropocene, what's the role of geoinformation science? What can we optimize or harness in order to better manage the Anthropocene? But in this case, we are talking, or I'm talking about the Anthropocene in the context of the disasters that we do have in the country or in the world. Which brings me to this slide with some interesting figures. Of course, we know, globally speaking, that disasters have been there since time immemorial, but if you look at the trend lines, then you realize that they are increasing over a period of time. If you plot a trend line in this graph, then you'll clearly see that it's moving upwards. So that's one thing in terms of the trends. But when you also look at the world in terms of disasters over the last 2 years, we can also argue that they are becoming more complex, of course, with a series of processes that drive these disasters. But over the last 2 years, we can also say the pandemic is altering the disaster landscape across different spaces. We know what it has done for sure in form of the pandemic or COVID-19 pandemic itself. But the most critical here is to also to have a look at how is the pandemic interacting with spaces that are disaster prone. So the challenges are increasing. How do we manage these two together? But this is also coming when the world sort of in the last 10, 15 years has sort of shifted in terms of the paradigm of how you look at disasters. We are more or less moving from the point of view of looking at them in terms of emergencies or in terms of responding to a disaster which has occurred towards a direction that builds resilience, that tries to avoid the occurrence of disasters. I'm stuck. Okay. Now, one of the interesting things when you look at those disaster processes moving and changing and being dynamic is that it's also visible that firms that are sort of focused on disaster business, in spite of the fact that the pandemic has altered the disaster geography or complicated it, they are making money. One of the interesting things, there is a firm, a German firm called Munich Re. If you are in the disaster science, maybe you have read about their reports. But just recently, in 2021, they are forecasting that their profits are increasing and are projected to increase even with those sort of adverse conditions that globally we are grappling with. So one can argue that disasters are also profitable in nature. So moving from that, we need to pick some kind of important messages just from the geographical dimension. This is a global map depicting the risk in different continents. There are some facts that are clear that we have known in time and space, that most of the developing countries are the most vulnerable. So this is just mapping people and where they are and the risk that is attached to those populations. You can now go to issues of vulnerability. You've had the map of the overall risk, and then we can come to vulnerability, looking at people and their capacities, and the geography is more or less the same. Africa and Asia are more in the adverse situation there. If you go to adaptive capacities, coupling a range of processes that are driving sort of disasters from the climate point of view, but also looking at what are those assets, what are those capacities, what are sort of the supportive systems available in countries, we still see the same thing from these sort of global data sets, that the adaptive capacities are more or less in countries that are developing. So that gives us some kind of a snapshot to understand where do we have disasters, more disasters, where do we have more vulnerable people globally. But if you talk about disasters, you need to conceptualize it very well, because many times anyway, you hear people talking about disasters more or less in an erroneous perspective. So what do we have to do? We can pick this sort of simplified conceptual framework. When we talk about disasters, really we are talking about 2 or 3 things. One, you need to have a hazard occurring before you can talk about a disaster. So you have that as a component. And then secondly, disasters are always happening in areas where you do have vulnerable people, those who cannot support themselves, those who cannot do certain things. So conceptually speaking, then we say, if you talk about disaster, then you have the hazard, then you have the vulnerable community. Once those two sort of come together, then you know that in a given geographic setting, you have a high risk of a disaster taking place. And once the risk is realized, then it translates from being a risk into a disaster situation. Therefore, what does it mean to talk about disaster resilience within this conceptual framework? Disaster resilience, therefore, must be approached from understanding these parameters. If we can enhance the capacities of people, we are lessening their vulnerability, and therefore they are becoming more resilient. If we are able to minimize the impact of the hazards that are occurring in given areas, then we are also contributing to building the capacities or the resilience of people. In that case, therefore, it's not a case of saying in Uganda we have a landslide, or we have floods, or we have earthquakes. The presence of landslides themselves is not enough to speak about disasters. If you had a very huge landslide occurring in the slopes of Mountain Elgon, and you don't have property and you don't have people in that area and the like, you can talk about a hazard taking place, but you cannot speak about a disaster taking place in that area. It can only be a disaster when you have vulnerable people or assets that have been affected by those processes. Which now brings me to this slide here, that when we speak about disasters, first of all, we have to understand the risk, which is computed from the point of view of the hazards, but also from the point of view of vulnerability. And we have this inform index, which is calculating the risk of countries with respect to a range of parameters, but which generally fit within that conceptual design. So you're looking at the hazards occurring, you are looking at exposure. So in exposure, there is a likelihood of a flood taking place in this area, but are there people in that specific area that is prone to floods? Then you can quantify and see what is at exposure. You can look at vulnerability. You can also evaluate the coping capacities. It gives you more or less the same picture as we saw below, but maybe what we have to do is to downscale this to Uganda specifically. If you're looking at the inform risk, then you have a range of these factors that have been calculated but fitting within that broader design to understand what are the hazards, how vulnerable are the communities, and what are the capacities. And Uganda has a number, the inform index of 6. It's from the bottom, it's around 21. I think it's 21 from the bottom. Anyway, the bottom line here is that the risk is much higher for obvious reasons that we know, either from the hazard perspective, interacting with the communities in different areas. It's not very difficult to sort of predict what will happen in future if you are looking at things from a macro level. Again, coming back here to Uganda, we know that a significant proportion of the hazards we get, which in most cases translate or drive towards disaster situations, can be categorized as hydrometeorological in nature. So hydrometeorological, you are relating them to what happens up there. Are you getting rainfall, and how much rainfall? Then you know the rainfall can either drive floods or it is driving landslides. But if they also fail, then you can talk about drought. All those can be bundled together as hydrometeorological hazards. So if you look into the future, these are images of projected changes in climate over Uganda using different concentration pathways, in other words, projecting what is likely to happen in future. Now, what you see clearly here, again at the macro level, is that it's projected that Uganda is likely to become wetter, okay? Now, if most of your hazards that are translating often into disaster are hydrometeorological in nature, then the question is if you're going to have increasing water availability over the space of Uganda, are you going to be able to handle that if you have been failing to handle that under previous conditions? It sort of presents both sort of a challenge, but it can also be an opportunity because you can also build the resilience on the basis of increasing water that you have at your disposal. So in essence, we need to understand our communities, we need to understand our people, we need to understand societies and what they are doing. This is a picture highlighting things from Mountain Elgon, the livelihood structure or livelihood systems. If we can boost this and enhance their capacities and incomes, then we can make a contribution towards disaster resilience. Which brings me to this definition, a rough definition of resilience. Now, speaking in a room which is having people from engineering background, perhaps you are looking at resilience in a more different way when you are looking at the infrastructure. But in a broader way, there is some kind of convergence that in simple terms, we are looking at capacity. Can people withstand the occurrence of certain events? If they can't withstand, are they able to recover in a short period of time and go back to their normal situations? Once they lack those elements or those tenets, then we know we are dealing with vulnerable communities. We can pick some kind of global parameters or indices that can still give us an indication of resilience at the country level. This is just a comparison. These are not ranks where you have numbers, but it's just picking a range of countries from Africa. So you can look at the GDP for the country. If it is low, then you know that at the country level, there are some things that are limited. You can look at the Human Development Index. These developed are generated by the UN more or less annually. You can look at the Inform. I have already spoken about it. The higher the number, the higher the risk. We also have the Gain Index here, which is looking at issues specific to climate change, but also bringing in aspects of vulnerability. We have the Sustainable Development Goals, and we can look at how countries have been performing with respect to the different targets. Then we also have the CRI resilience, again, more focused on the climate. Now, with all this, of course, we can make some kind of compound calculations. If I was now putting ranks, I should be able to situate all these countries and rank them. But bottom line is that if you're looking at all these, then our countries are still at that level where they need to pull up the socks. Which now brings me to the Sendai framework for disaster risk reduction 2015-2030. So the overriding global agenda here is to build resilience and reduce the adverse impact from disasters. When you look at the global development agenda, you can pick out maybe 3 important sort of processes or components. Broadly speaking, we do have the Sustainable Development Goals, 17 in number, 169 targets. We have the Paris Agreement. You are familiar with it. The idea there is to try and keep the temperature rise thresholds within a range of 1.5 to 2 degrees centigrade, which links nicely to issues of these hydrometeorological sort of disasters. And then we come specifically for issues of disasters. We have the Sendai framework for disaster risk reduction to be monitored for a period of 15 years, starting from 2015 to 2030. If you interrogate the Sendai framework further, because that gives us more or less the vehicle, a very specific vehicle, moving towards improving disaster resilience. What do we see? We have 7 sort of targets here. The first 4 targets of the Sendai framework are more focused on reducing something. So when you talk about the first one, you are looking at reducing the mortality rate. And we have baseline data, or it's based on baseline data. Between 2005 and 2015, we were working globally with the Hugo framework of action, so a lot was collected. So from there going upwards, we are dealing with the Sendai framework. So when you talk about the first one, the first target, which is focusing on mortality, you want to see people who are dying from disasters, disaster-related events between 2015 and 2030. Has the number reduced compared to the period between 2005 to 2015? And you are calculating these over 100,000 persons. So what do you have? How many have died with respect to a number of 100,000? So a range of things that you have in there. You want to reduce mortality. You also want to reduce the number of people who have been affected. If they have not died, once an event, a disaster event has occurred, how many people have been affected? How many have been displaced? In some cases, some are even lost and they are missing. So you have some baselines and you want to see, you are going to monitor progress with respect to comparing those numbers. What was it before? What is it now? You can also look at loss in terms of assets. If a disaster event occurs, what is, for example, the extent of agricultural areas that have been affected now? Are you able to quantify? So you have a range of issues there that are geared towards reducing certain things, including the critical infrastructure. In the Sendai framework, if something happens, like we have a flood, we had floods in Kasese, and then you are looking at the infrastructure, you're looking at the roads that have been affected by that specific event. Are we able to monitor and say that these things are reducing over a period of time? On the other hand, of course, you also have those which are more focused towards increments. You want to increase the number of countries with policies and strategies that are focused on disaster risk reduction. You want to increase the cooperation or partnerships. You also want to increase access to early warning information. Literally looking at developing systems that can warn people, and if they are warned in time, then you can reduce the losses, you can reduce the mortality. And again, the numbers come in. How many people are you able to reach in terms of early warning? You can compute with respect to 100,000. What was it before and what is it now? 100,000 people. So that's what the Sendai framework is targeting. Again, I'm having problems. Please help me. Okay, thank you very much. So that's the target. Now, when it comes to technology, geospatial technology, we also find that the Sendai framework is very, very explicit on harnessing geoinformation or geospatial science in addressing a range of issues that could be in form of risk assessment, it could be in terms of providing real-time information, it can be in form of building scientific capacity in the use of geoinformation science, it could be in form of dissemination of information. So geospatial science is nicely captured in terms of how can it be utilized to facilitate countries to realize those targets and goals under the Sendai framework. Now, moving from there, of course, we know that geospatial science and technology has evolved over time. This is having so many components, but it is not exhaustive in nature. The technology has developed from the sense of data, science, users, business, and also taking it to scale. These days, even when you have your smartphone, clearly, you can utilize science technology. And we can also look at it from the point of view of the increase in importance, but literally here looking at the entire ecosystem from the technology to the business angle, and that also takes you to other sort of drivers of the utility and getting the application to a higher level. You can now talk about Internet of Things, artificial intelligence and geospatial technology, cloud computing, wireless and broadband issues, as well as big data. So if we couple this sort of entire architecture, then one can believe and can be convinced that really, if we were able to optimize and maximize it, then we would be making a very huge contribution towards society values, building the capacities of people, getting the technology to the end user, or in the disaster risk management sort of language, we always talk about the last mile. That last mile person is not Professor Gidudu, but perhaps his grandmother somewhere there in the village. Is he able to benefit from this sort of technological growth? And many things, again, this is not news if you are looking at it from Earth observation angle specifically, or satellite remote sensing. We also see many, many developments that have occurred over a period of time. Which now brings me to this question. With that knowledge, with that understanding, and with those opportunities, one could ask that, have we optimized geospatial science for disaster resilience in Africa? It's a big calling, or it's a big question. In the light of adequate data, you cannot answer it directly, but we can pick out some elements that can give us a little bit of an understanding of how far we have traveled. But we can start with what one can take to be the basic geography. If you are speaking about things from the scale of Africa as a continent, then we must appreciate that it's a very huge and heterogeneous continent that can swallow many big powers if you are looking at the size per se, and that's what you have here. But with respect to the technology, we are also seeing, maybe the slide is not very clear here, but we know that over a period of time, African countries are increasingly interested in space science, and there are so many that have sent missions up there. And I think whether it is this year or last year, Uganda was also announcing that it wants to go in this business or this science. So we are looking forward to including Uganda in that. But overall, then we need to assess, first of all, have an understanding of the existing capacities. And here is some work, I forgot to put the source here, but here is some work done by Professor Sendai Woldai, and it's published in 2020. He is a member of the African Association of Remote Sensing, and I know there are members who are present here in this room. So they did some kind of an inventory on some of the things, understanding the organizations that are involved in geoinformation science, and here you have a range spanning from issues of those that are involved in space science, the agencies, those that have satellite stations. You are looking at existence of associations, whether they are national or they are regional, and a range of things, including sort of academic institutions. In here, you get some data that is projecting the academic institutions that are involved in training geoinformation science, either at certificate level or at master's level or at PhD level. And the graph is not clear on the slide, but Uganda is somewhere there with some information which was picked, and of course includes Makerere University. So, where are we? I want to just highlight a few things here since the moderator is warning me. So when you look at what has been done, one can argue that when you look at things in time, if you do a temporal analysis, then you realize that in Africa, it's no longer a case of data, it's no longer a case of softwares. Those who were there 20 years ago were paying high amounts to get a Landsat image. You were paying stupid money for these softwares. We still pay, but in relative terms, the rates have gone down. And we do have systems, Earth observation systems that have been developed. Even here at Makerere, we have the GeoNetcast or EO systems where you are able to get huge amount of data, remotely sensed data, that you can utilize to do assessments for DRR. We have gone into the business of unmanned aerial vehicles, and you have an example here. My colleagues here said that we already training people building capacities in the use of UAV in terms of infrastructure monitoring. And when you talk about infrastructure, then that fits well with target 4 of the Sendai framework for disaster risk reduction. If you are able to monitor, then you can provide information that can sort of help in reducing the impact on the infrastructure. We have so many portals that are available. So if you say, I don't have the techniques of doing this myself, you could go to some existing portals and pick some data which is already existing. We've had studies at continental level. This is an example from South Africa based on the work of Walls, where he was monitoring progress towards the Sendai framework, specifically looking at target C, which is looking at what can be lost when a disaster occurs. If we come, then we can come back to Uganda. Then we can also have some examples, really even at the basic level of constructing a digital elevation model. One can start having some implications or understanding why you are having landslides occurring in the mountains there. But if you look at it from the point of view of hydrological connectivity, by inspecting this sort of image, then you can also understand that you are having landslides in Bududa, at the same time you are also having floods in Slonko, by way of inspecting that image. We have had cases of landslides in the highlands there, and we can use our images to understand the context, whether it's a panchromatic image, you are able to see where are they occurring, and you can do characterization. We have sort of developed from studies undertaken here, developed some kind of databases by collecting geospatial data from the field, which sort of has enabled us to understand the patterns, understand the hotspots and bright spots of landslide occurrence in those areas. We are also able to use sort of imagery analysis to understand where are the pressures that are also driving some of the disasters we have obtained in the past. And if you look at this image of Mountain Elgon, it gives you a little bit of understanding the park boundaries and how people over time have entered into the boundaries. And if you look at what happened in 2010, then it's very clear that where you had encroachment in the parks are also sites that experienced landslides that were disastrous in those areas. We have done sort of geospatial-based morphometric analysis. It's not everywhere that landslides are occurring, but you also have specific geologies and specific soil types where you have them. We have also looked at issues of now, we understand a little bit of the hazards. Do we have an idea of the vulnerability, looking at people and their resources and what elements, what we call elements at risk, are prone or are in those areas where landslides are likely to occur. And we have also looked at issues of regeneration of sites, sort of invoking NDVI data and looking at the areas before and after and how long has it taken to regenerate. And overall, at the country level, then we also have a series of sort of maps, hazard maps that have been developed at NECOC that are constituting the risk profile for the country. Would one therefore argue that we have adequacy in terms of optimizing and maximizing geospatial science for disaster resilience? It's also something that is worth interrogating at a different level. Now, we do have this data that has been developed at a global level, and it's looking at the geospatial readiness. They have developed the so-called Geospatial Readiness Index, premised on about 5 parameters. What is interesting here is that when you look at that, Uganda is actually, when you look at the scores, it's number 2 of the bottom 5 countries. So that's in one way or the other indicating in nature that we have done something, but when analyzed at another level, we still have some distance or some gaps to move. So if we are to unpack that index further, we have 5 parameters or factors there. The first one here is looking at the data infrastructure ranking according to the data infrastructure. So in infrastructure, you're looking at things like, do you have a spatial data infrastructure? Do you have surveying, national surveying sort of departments at the national level? Do you have associations, and how are they sort of moving the geospatial ecosystem at the country level? So what you note, again, the text is not clear here, but this one gives you those at the higher rank, this one gives you those at the lower rank, and Uganda is about just there. You move to the second parameter used here. It's looking at policies. Again, colors may not be very clear here. And then we can look at the spatial distribution of countries. So policies that can aid the implementation of geospatial science that are driving the process at the national level. We are not among those in the lower bottom, but we also have some constraints here and there as a country, especially when you come to issues of using UAV. And then you come to the capacity, institutional capacity ranking. This is where you are interrogating the institutions involved in training, because those ones should output people that ultimately are going to drive the agenda at the country level. Those who are able, those who are ready. When you interrogate this, again, Uganda is part of those in the lower bottom. Then you come to the usual rankings here. Again, the slide may not be clear, but you are now looking at the uptake. How many institutions are able to make decisions based on analytics of geospatial data? And then lastly, you are looking at the industrial capacity, the business about these things. Are we able to train people who can come up with solutions, or can come up with apps and can drive the business agenda? They are already convinced that geoinformation is the thing, and they are taking advantage to make business. In other words, we are looking at entrepreneurship and a thriving business environment. So, in brief, what can I say summarizing the entire chain? If you look at the value chain of geospatial technology with respect to the hierarchies of disaster risk management in Uganda, of course, you have this graph. It's spanning all the way from the president's office, and it has to go to the lowest level. In terms of technical capacity, availability, and generation of information, right now one can strongly argue that it's more limited, it's more focused to the national level. You will not go to many districts and you find environmental, rather officers who are doing these analytics at that level. Rather, in most cases, they are highly waiting to get what comes from the national level. And then secondly, as you may have realized from the slides, if you fit this with respect to the Sendai framework, what we have done is largely skewed towards understanding risk, and there is limited work that has been done towards building resilience. There is this more attention given especially to early warning systems and optimizing that and harnessing geospatial technology to make sure that those people who are in exposed areas can always get timely information that can help them. And then obviously, then we are talking about the lack of effective harnessing of data science to enable us reach the last mile. Again, last mile is not the technical officer involved at NECOC or a person technically present here at Makerere who can do the analytics. It's that person who is in Soroti who has to understand that in the next 24 hours, a flood is going to occur and you are located in an area that is likely to be impacted by the occurrence of that slide. So where is the problem? Of course, when you interrogate this, you can find so many causative factors to that distance which is there, but we do not have time to go into that. What one can observe by way of this graph is that we have the technology which is rapidly sort of developing. One can argue that the technology is developing at an exponential rate, and the capacities we are building are just that they are maybe a little bit linear. So with that in mind, then you have sort of this increasing gap over a period of time. But when you look at this graph here, it is also promising. In time, again, the numbers are not clear, but it's giving the growth of the industry between 2013 and 2029. Then you realize that the geospatial industry has been rapidly increasing and now valued at about 439 billions in 2020. So that sort of puts us in a situation that we can lament about these things, but there is also an opportunity which we need to sort of harness and maximize and make sure that we can benefit from this. Now, if you go again to the conceptual definition, by way of getting people also in this business, you are providing opportunities, which opportunities will cascade up to the lowest level and can boost resilience. If you can get a graduate here employed and is getting money from this industry, you'll be sure that he's sending something back to the villages or back to the areas and making a contribution towards that resilience. So we have quite some spaces that we need to fill, which spaces now for us who are here and are involved in the business of capacity development, we need to do something bigger than what we are doing. Those who are outside there at the policy level, they need to do some things much higher than what they are doing presently. And in so doing, then we can broadly at the macro level move towards disaster resilience in all aspects. The mic is no longer working, but it's working now. People can hear me. Okay, so I can abandon it. Now what?
Hello, hello, hello. Hello.
So anyway, if they are not hearing me, at least they are seeing the slide. This is the last slide. This is the last slide I think I have, just to summarize a few things. That looking at this from the point of view of Anthropocene, of course, we can say that the human footprints, terrestrial footprints are there, and they are increasing, and those footprints in some areas are driving sort of at the disaster geography. There has been some increase, there is increase in geospatial science, but our utility of this is suboptimal. The technology is growing more than we can handle, so we need to learn our So, and then some infrastructures do exist, but again, we need to enhance this to make sure that we are able to make a huge contribution. You also see most of the work that we have done in Uganda, but indeed in Africa, is limited at scale. You find more of the work at micro or small scale rather than those that are bringing out things at a higher level. We need to enhance the enterprise development premised on geoscience technology and build the necessary partnerships. Now, some of these things cannot be fast-tracked, so we have to be patient, but if we have the will and the dedication, then over a period of time, I'm sure we are going to be there. So these are just some of the references, and I will end by thanking you and also depicting that very nice image all the way from Kabale. Thank you very much.